Let's give a big round of applause to Hjalmar.
Thank you all, and thanks Brian and team for putting on this amazing event. I have very fond memories from this room because this is where I launched the data market back in the day with a full room of people, and that was an excellent event. Anyway, so I'm here to talk a little bit about spreadsheets and the nature of spreadsheets. And you probably think by now that this is going to be the most boring talk of the day. It might well be, but we'll see. So a little bit of a background. So I've been looking at how people work with data and what people do with data for the majority of my life, but especially through kind of the data market journey. And then data market was acquired by a company called Qlik, which is a business intelligence company. And there I was specifically making tools. I was supposed to make it easy to work with data. And Qlik's promise, just like Power BI's promise and Tableau's promise, which are two of our Qlik's biggest competitors, was that we're going to make tools that were so easy and so approachable that any user could answer their own questions and make their own analysis. The reality of it is that none of these tools do that. What happens is that there are a few people that become specialists in using these tools. They go over the pretty steep learning curve that is involved, and they then serve 10 to 50 other people within the organization with their analytics needs. However, there is a tool that pretty much every business user and pretty much every person in the world uses to some extent to work with data, and that's spreadsheets. And it's usually the first thing that people bring up whenever they have to do anything that has to do with data, whether it's Excel or Google Sheets or some of the much smaller solutions that are out there. Spreadsheets rule the world in many ways, and and we run a spreadsheet. So, without further ado, I'll start off with this funny quote I found somewhere. So essentially, the economy is run of two things: the combustion engine and Microsoft Excel. I think that's pretty close to truth. But if we kind of step back in history a little bit, so people often, they contrast like text and unstructured data against, the humanity of text and unstructured data and the spoken language with structured data. However, structured data has been with us for a very long time. Some of the earliest writings in the world are actually structured data tables, in this case from the Sumerian period. And what this is detailing is how many bushels of wheat somebody owes to someone else. So it's essentially a spreadsheet. I think calculations may have been a little bit difficult to change, but at least that's what they are. Throughout history, then, people have gone through several iterations of this. And in the Middle Ages, it's a fascinating category of literature, which is essentially books filled with tables. The reason for that is that calculations were really expensive. So people would do calculations, the expensive calculations, they would write them in books and then would ship the books off. So if you had to calculate, for example, what a certain interest rate over a certain period of time meant, what the factor was that you had to multiply with, you would look that up in a pre-calculated table and then apply a single multiplication number to your thing so that you don't have to do a series of very complicated calculations. There are also other things that have to do with things like, look more like statistical data from today's census offices and statistical bureaus. So basically facts about the world, like this. I love this title, 1 million of facts of correct data. And the title actually goes on and is hilarious as it goes through. But these are more kind of, facts about the world, numerical facts about the world that are printed in books and then distributed. And this is the way statistics were distributed until well into the 2000s, where most of the statistics offices in the world started moving to the internet. Some of them haven't really gotten the difference between these two medium yet. And then there are things that are used for navigation. So things that help you, basically tables that helped you find out where in the world you were and how to set your course to go somewhere else. This is actually not one of those. We skipped through one of those. But this table here is actually a super interesting one. So this book was made by a purpose-built machine. The machine was both a calculator and a printer, and it was built just to print this book. It basically was a bunch of gears that would crank, and they would turn on the numbers. They would turn the printed letters, and then they would kind of do the calculations, print them on the page. And this is one of these series of calculations that I was talking about earlier, where you would look up that if the accrued interest over 5 years and the interest rate is 8.5%, then you could look that up in a table like this. There's also, like, calculating sine and cosine and things like that. People printed large tables for. And then in about 30 or almost 40 years ago comes the spreadsheet, which is really the first tool, at least first PC tool, that allowed people to work with structured data. And it was more transformational than most people realize. So Steve Jobs, for example, said that Apple would not have become the company that it became had it not been for the fact that VisiCalc, the first spreadsheet, was written for Apple II, and that was the first time PC computers made it into normal businesses. About 25% of Apple II computers that were sold for that sole purpose. It was sold for the purpose of running VisiCalc within businesses. And that's no small feat. And then came with that a whole set of other business software. So basically, spreadsheets were the first business software. And actually, if you look at it, they were not just business software. They were not just purpose-built business software. It was a platform, because what came with it were templates for things that there wasn't any purpose-built software for, like doing the budgeting, like doing invoicing, like doing accounting. So all of these things were basically the spreadsheet templates that were run within VisiCalc. But then some of these kind of purpose-built tools started splitting out and becoming their own tools that were purpose-built and in some ways better to deal with these purposeful tasks. So fast forward, what essentially happened, VisiCalc came to market in 1978. They ruled the market until 1984 when Lotus 123 came out. They had essentially what Lotus 123 had going for them is that they had the first charts ever in spreadsheets, but also they allowed you to make arbitrary calculations. In VisiCalc, you could only, because it was calculated from cell A1 and then line by line down, you could only make calculations that referred to cells that were up and to the left. What Lotus 123 found out to do is how you could put the data anywhere and you could refer to any cell, which allowed a lot more freedom in the creation. Lotus 123 rules for a while, and then Excel comes around, and that's basically ruled the world ever since, although we are in a very interesting period now where Excel and Google Sheets are both significant players in the market. This has always been a market that's been dominated by one player, except for now, where Google Sheets is gradually taking over market share, but it's taking longer than you would think because, so young people use Google Sheets, young companies use Google Sheets, but established organizations use Excel. So young people that join established organizations get the Office suite thrown at them and have to get to the Microsoft way. There's also the fact that Excel is much more powerful, and especially Excel on Windows and not on Mac is much more powerful than Google Sheets. So if you're working with a lot of data or if you're working with really complex calculations, then all the hardcore spreadsheet nerds are doing that on Excel on Windows. However, even Excel people go to Google Sheets is when they need to collaborate on something, because Microsoft has not come up with anything that's anywhere close to as good for that as Google Sheets. So there's a big overlap between the two user groups, but there are at least 800 million people in the world that are using Excel, 1.2 billion people that are licensed on it, and somewhere between 160 and 180 million people that are using Google Sheets. And again, there's a big overlap between these two groups. So 800 million people use spreadsheets, a few other numbers, 1.2 billion, I already said. 50% of those are believed to kind of create their own content. The other people are essentially just consuming stuff in there, so they use Excel as a reader. 2% of all computed time in the world is spent in Excel. If you make that if you calculate that into a typical work day, it means 8 to 20 minutes, and it kind of makes sense. And then Excel is the #1 sought after computer skill in job ads worldwide. So this is a fairly big deal. Now, what people are creating in spreadsheets, and this kind of, I became fascinated with why is Excel everywhere? Why are spreadsheets everywhere? And what I realized is that spreadsheets are flexible enough and available enough to be the answer to the question, how can I do this without talking to IT? So they're basically a way for people to avoid the cumbersome task of kind of talking to and then waiting for IT to solve their IT solutions. And they allow normal people, they're flexible enough and approachable enough to allow normal people to create small databases, to create simple models, or create essentially programs, because, and I love to say this, and I think this is probably a good audience to talk about it with, spreadsheets are programs. Instead of having code that you execute from the first line and down, you are encoding a relationship between data elements that live in cells. And what is more is that it is, so two of the kind of hottest words in computer science these days is functional and reactive, and spreadsheets are both functional and reactive, meaning on the one hand, you are just encoding the relationship, the computer decides the execution order, and for any change, you change the state of the whole thing, and there's no specified flow through there. And the second thing is that the reactive part, it gives you instant feedback. As soon as you change something, everything updates on the fly, and you get this visual feedback that you typically don't get when you're writing software, because then you're writing software, you have your mental model in your head that you're trying to get in code, then you compile or have to do some other step to actually see the effects of what you changed. In the spreadsheet, you see immediately the effects of what you changed. So I've gone through several exercises. So before I go there, I should say people have proven that spreadsheets are Turing complete, which means that you can program anything in a spreadsheet. Not that you should, but you could. I've gone through several exercises of kind of changing simple spreadsheets into JavaScript. So this is an easy one. And this would literally take you a minute to create and maybe 2 minutes to create in JavaScript. But take something a little bit more complicated. And this spreadsheet that takes maybe 20 minutes to build out with all the formulas, a fairly typical kind of projection, is actually fairly involved JavaScript code. But the difference is, when you've written the JavaScript code, you've only written the logic. You still haven't written the web interface to actually display that. You haven't put up the server software to serve it up. You haven't put in place the database software to save your changes to. And if you were to do that, you would easily have hundreds, if not thousands of lines of code, several different libraries, 5 different programming languages. You would probably have something like SQL, Python, JavaScript, HTML, and CSS all involved in kind of creating that solution. And it would take you a pretty long time, and it would be a fairly involved process. And this is something that people can just do on their own in their offices, which is pretty amazing. Now, I'm not saying these things are perfect, and we'll come to that. But we've been kind of diving into just spreadsheets. We've been collecting spreadsheets from the wild. They've mainly come from academia, where people have done some interesting research on this. So we've tried to kind of understand what people are doing. So of the spreadsheets, of the roughly 20,000 spreadsheets that we analyzed for this, or actually 15,000 for this particular slide, just over 40% of them have no formulas. So that tells me they're just databases. They're just small databases. But almost 60% of them have formulas in them. Here are the most common formulas. So sum, if, now. You probably don't even know the kind of number 26 or number 29 one on the list. The thing is, this is a very kind of long tail. So there are 538 formulas in Excel. But the 30 most common of them cover 94% of the files, not of the formulas, but of the files. And that's an interesting thing. And then also the file size drops off very quickly. People aren't working with terribly large spreadsheets normally. 96% of all files have fewer than 100,000 cells with content in them. Now, what are people doing? I've talked about kind of the small databases. So they're just essentially no formulas, just data. And that's what you're doing. Then you have models, and I kind of like to talk about 3 types of models. It's projections, where you have a small amount of data, and you're calculating a lot of data from there, so you have a small amount of assumptions, and you're using that to calculate a lot of data. Separately, you have analysis, where you have a lot of data, often exported from somewhere, and you are trying to understand it by calculating a small amount of data to tell you something more about it. And then you have a bunch of random things that are called calculators, where the input and output are more balanced. And the final thing, the third category of spreadsheets, the one that was most invisible to me until I started diving into this, is that people are running entire business processes off of spreadsheets. There's that template that every department has to fill out once a month and then send somewhere, and then it goes into some other system or a back office where some poor people have to aggregate the data and put it into other systems and then create a slide for the next board meeting, or just the low-level processes of ordering lunch. So you have to fill in the spreadsheet before 11:30, tell us what you want to eat, and then the order goes out. So, and everything in between. Those are all interesting. But what people are creating is limited in many ways, to say the least. So first of all, it's stuck in spreadsheets as clients. So if you create something in a spreadsheet, you have to send people to that spreadsheet to use it. So you create something in Excel, they will have to open Excel to use it, and you're limited to the user interface that Excel gives you. You're also sending, typically the most common way of distributing spreadsheets is actually emailing them, which is fascinating. Obviously, Dropbox and then Office 365 and obviously Google Sheets have kind of taken some of that pain away, but most of the business world still just emails spreadsheets around. And that means that you have multiple versions, you don't know who has which version. If somebody wants to change something, you have kind of conflicts, and there are all sorts of nasty things about that. So they're difficult to maintain, share, and control access to. And then, if you look at the spreadsheet, even if people know really well what they're doing and they're really sophisticated, the user experience of using something created in a spreadsheet is far from what we've gotten used to from our phones or from modern web applications. That is, and that's no small thing. So I started thinking, what if you could take what people already know how to do in spreadsheets, what they've already done or what they know how to do in spreadsheets, and give them a way to turn these things into modern web applications without learning any new skills, or at least without learning a lot of new skills. And that sounds like a big task, but I think we've kind of come up with a way to make it super interesting. So I'll show you a quick demo, and then hopefully we'll have a little bit of time to talk about it after. But if I move to, I'll start by showing you a spreadsheet. So is this visible? One back. So this is definitely a model. This is something that there's no better software than spreadsheets to do exactly this. So you have you're building a business model or business projection. You have a handful or two of assumptions up in the blue box there, and you use that to calculate time series. So this is by month, some visitor numbers, and they turn into revenue numbers. So and what happens here? Somebody has been tasked with making this. Well, typically, it isn't this clean. There will be some side calculations up there. There will be some notes that you've made for yourself that you don't want others to see. So before you send it off, you'll be cleaning it out. You will then be emailing it out, and then the conversation starts. So I don't believe this assumption here. What if this is 8%, and then people start going back and forth on that. Now, what the person that built this spreadsheet would have done if they were a grid user, which they can't because grid isn't available yet, but what they would have done is that they would have gone to grid. They would have uploaded that spreadsheet. So we're working off of that same spreadsheet here. And the editor I'm showing you now is a Markdown editor. That was an easy way for us to get started, but I'll also show you where we're going with that, because we don't think that the typical spreadsheet people will be learning Markdown. Markdown, for those that don't know, is just a simple syntax that allows you to format things. So here is, demo. Oh, what's happening? Oh, there we go. Demo at material.is. And then I can write some text, nothing interesting about that. Where this gets interesting is if I want to pull in data from the spreadsheet itself. So down in line 39, from C39 to AL39, we have the revenue. So I just do like I know how to from Excel, equals C39, AL39. Oh, look at that. Oh, where do we go? Here. So 475, 998. Yep, these are my numbers. And the reason we display it like this is we think people feel good in spreadsheets. They know spreadsheets, and we want them to kind of understand, yeah, this is just like my data in here. But we want to see this as a column chart. And then we do that. So you can do this in a lot of visualization software. We're very kind of spreadsheet specific, so we make it very easy on top of spreadsheets. But what we do, and nobody else in the world does, is that we don't only import the numbers, we actually import the model behind it as well. So we are not just importing the 475, 998, but we're importing the formulas behind it. So what you can do is you can go here. So if you want people to play with the assumption we had in here, you do equals B8, yep, 10%, but let's make that a slider. Oh, here's a slider, and so you can play around with the model, and it calculates on the fly. So essentially what we've done is we've recreated the spreadsheet engine in a browser. Now, that alone gives you a lot of power to kind of take your spreadsheet and do something with them. But what we've also done is that we've given people that know how to write spreadsheets a way to do stuff on the web they never knew they could. I'll give you two quick examples of that. So the first one being, it's very likely here that I wanted to see the sum of the first year. And that number doesn't exist in the spreadsheet. So we would probably go here, we'd do year 1, and then we'd sum up here, save the file, re-import it. You can do all of that in Grid. Actually, we pick up on changes in the file. If it's stored in Dropbox, we just know it was changed, and then we recompile, so it's instantly available. But what's even cooler than that is that I don't have to do that. I just say expected revenue in year 1 is equals sum C39 and 39, and here we have the number. And that is now a part of the model, and that's nowhere in the spreadsheet itself. I can even go further, and I can say, let's copy this one, which is equals if this number is higher than 20,000, it is great, and otherwise it is pathetic. Oh, it's pathetic. No, we have to, oh, it's great, it's pathetic, it's great, it's pathetic. So anyway, this is just a small example to show you, so, as we build this out, any property, any color, any location, any visibility of anything on this page can be controlled with spreadsheet formulas. So we've now taken what was something you could do in a spreadsheet to enable you to use those spreadsheet skills and those formulas that people know from spreadsheets to program things on the web. I won't go through it here in detail, but we've gone as far as kind of doing the mind experiment of how you'd write something like Tetris in this. Tetris is just a spreadsheet. It's easy to kind of to understand how the logic would work, but we're taking this, so that's not the business case, but we're definitely going to do it. So next year I'll show you a kind of a Tetris running off of a spreadsheet in Grid. So with that, I'll leave you. So we are kind of, the stage we're at the moment is we're aiming for an alpha test of this in January and beta next summer, and then we hopefully have a product to sell by the end of next summer. We just started this 2 months ago, so it's been pretty good progress since. So thank you.
It's great to see that the web actually might be made up of spreadsheets.